Okay, good morning, everyone. Okay, right now, this is what we have seen in the last class. So, like how to work with the stacking. I said about vertical stacking and horizontal stacking, and even I said about what is a concatenate. So after that, so you have other methods like yes. So there is other methods you find here. So what are the other methods you can find is, so these are other methods of the function like append when there is an insert. So there is an append, insert, and one more is delete. Okay, you have a methods like insert up. So insert, append, and delete. So these are called other methods. So there is an append method and there is an insert method. And one more method you have is a delete. Yes. So these are other methods. See, all these are not mutable operations. These are immutable operations. But actually NumPy array is a mutable. See, array is a mutable means where you can do only updating, but remaining operations you cannot do it. Only updating can be done, but remaining operations you cannot do it. Only updation you can do it, right? So this is a now this is a first function which is called as an append. So append is nothing but adding at the end of the rows, adding as a rows or adding as what? Columns. So it is look like a stack only. But here it is trying to append the elements. It is trying to append the elements or it is trying to append what? Rows or columns. So that is done by using a method called which one? Append. Now if you see the syntax of this append method, if you see the append method here, so this is a syntax of append here. So what append will do is it will try to add values at the end of the array. Append means always it will add at the end. Append means always it will add at the end. So you can see the NumPy append function in Python library is used for adding values to the end of the existing NumPy array. It is important to note that NumPy.append does not modify the original array in place. I said no, append is not a mutable, it is a immutable. Instead of that, it returns a new array with the appended values. And if you see the syntax of this is, you are writing NumPy dot append. You have to give the name of the array. You have to give the name of the array. You have to give the name of the array, only one array, name of the array, and you have to give the what is the values you want to add it, and you want to add these values along with the access, and what is the default access is some zero or none, right? Actually, so in syntax it is given none, but it will append along with the columns. Rows and columns can be defined by using which one? Access. But after appending it, it will not do the changes in the same array, original array. It will not do the changes in original array. It will return a new array with the appended values. It will return new array with appended values. So let me tell you about this, how this append will work. So here I'm writing. So here I'm trying to say import numpy as np. So here I'm creating an array. So this is an array called single dimensional array. Okay, so this is a single dimensional array, right? np dot array, and you're trying to add how many values here? 4 values. Then here, see here, print a and a dot shape. So what is the shape of this array is? It is having 4 values. Now I'm writing b equal to np dot append. np dot append. I'm trying to write here a. What is a here? Array. And define how many values you want to add it. For example, I write it as a scalar. So what I've given, I just given as a scalar. Scalar means 1 as an individual value. I've given it as a individual value. Means you're trying to add one value or more than one value, one value. But after adding, it will return one new array. It will return one new array. So what is that new array is B. So here now one element is added or not? Yes. But it will add at the end of the array. It will add at the end of the array. So that is the append. Now I'm trying to create an array of two dimensional where I said 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is the two dimensional array with 2 rows and 3 columns. I created two dimensional array with 3 rows and 2 rows and 3 columns. Now I'm trying to say a d equal to np dot array. So I want to append. I want to add the values. Now what values I want to add is, I want to add 7. I'm trying to add 7 comma, I said here 8. So how many values I'm adding here? Two values here, 7 and 8. I just given 7 and 8, but it is given an error here. So field elements must be 2 or 3 tuples got which one? 7. It means now you have how many rows are there? So how many rows are, what is the name? Yes, what is the name of the array is C. And here I'm trying to say 7 comma 8. But what it is given? Field elements must be 2 or 3 tuples. Got which one? Sorry. What is a, sorry, append. So what is the name of this is append. So here you are trying to add how many elements here? 2 elements. Now see, so this is my array. Okay, this is my array. So this is an array contain 2 rows and 3 values, right? So that is 1, 2, 3 and 4, 5, 6. 1, 2, 3, 4, 5, 6. Now here you are adding these two values. So you are adding these two values along with the access. You are adding these two values along with the access. Now, if I'm trying to print the D, now you can see 1, 2, 3, 4, 5, 6, 7, 8. Means it is written as which array? Yeah, it is written as which array? Single dimensional array n dot d dot. If I say dimension, what is the dimension is here? 1. But suppose I'm trying to say C equal to np dot append or E equal to some np dot append. I'm writing here C comma 7 comma 8. 7 comma 8 and I'm writing here access what here? 0. I've just written here access 0. Now when C comma 7 8 7 comma 8, here I said access 0. But when I say access 0, now you can see all the input. What is the name of the array is C. And C is which array here? Two-dimensional array with two rows and what is that? Yes. All the input arrays must have the same number of dimensions, but the array at index 0 has two dimensions. And array at index 1 has what? One dimension. Means what will happen here? Suppose I change this access 0 to what? Access 1. But even though it is given as what here? Error. So why suppose you want to append? What do you want to append? What do you want to append? A row or column? You want to append either row or what is that? Column. Now here I said access 0. Now when I say access 0, now still it is giving same error, right? So here all the input array dimension except for the concatenation access must match actually, but along dimension 1, the array index as 0, but size is given as what? 3. So what is the meaning of this is the number of elements. I try to increase the number of elements saying 7, 8, and 9. How many elements I have given? 7, 8, and 9. But what is access 0 is? What is access 0 is? Access 0 is along with the, yes. You have a two access 0 and one more is access 1. If you run this, now it is added as one row or not? Yes. It is added as one row with how many columns here? 3 columns. Okay, but if you don't give the access, it will take this array as which array? Flattened array. And then it will try to append how many elements here? 2 elements. But if it is a two-dimensional array, then you have to take the same. Dimension must be the array which you are adding, the elements which you are adding, that dimension must be what here? Same. I mean, if C is a two-dimensional array, the values what you are adding should be what? Two dimension. But you are adding this along with which access? Row. Access 0 is nothing but what here? Row. In the same way, if I am writing F equal to np dot append C comma, I am writing a 10. Okay, I'm writing a 10 commas here. I'll write like this. Okay, 10 comma 20 comma 30. 10 comma 20 comma 30. I said here access 1. Access 1 is nothing but what here? Column is. Access 1 is nothing but what? Column. Now it is given error again. So why? Because you required an array with the dimension of, now you are writing along with the columns. Now here I'm writing 10, okay, 10, 20, and here I said what? 30. I said 10, 20, 30. Now this is which array? 2D array. With how many rows? 3 rows. And with how many columns? 1 column. We have to close this. Extra, no? So here 3 rows. And with how many columns here? 1 column. How many rows are there here? Yeah, 3 columns. What I said here, axis 1. So 10, 20, 30. That's correct only. The array index at 0 has size at 2 and index at has size 1. Yeah, because your matrix is C, right? 2 are there. Sorry. It is having how many columns? Sorry. 2 rows are there, no? Yes. So I thought of this array. This is having 3 rows and 3 columns, but this is having 2 rows and 3 columns. 2 rows and 3 columns. So you are adding along with the axis. See here, you are adding along with the axis 1. You are adding along with the axis 1. Now when you say print F, now it is try to add 2 columns. Now 10 and one more is what? 20. So now append it will add at the end. So append method, what it will do, it will add at the end of the array. So if it is a single dimensional array, no problem. See, this is single dimensional array with a 10, 20, 30, okay, 40. If you are writing append, so it will append at the end. Okay. And this will be written into one new array. And what is that new array is B. Okay. Then if it is a two-dimensional array, if it is a two-dimensional array, now here I've taken the number of rows and columns. Now 1, 2, 3, and 4, 5, 6, and 7, 1, 2, 3, 4, 5, 6. Now here, this is a matrix with how many rows and how many columns? 2 rows and 3 columns. And it is 1, 2, 3, and 4, 5, 6. Now this is my array. Now this is an array called C. And if I'm trying to write np dot append C 7 comma 8 means it will convert this array into which array? Flattened array means 1D array. 1, 2, 3, 4, 5, 6, and it will append how many elements? 2 elements. That is 7 and one more is what? 8. One is 7 and one more is a 8. Okay, 7 and 8. Suppose if the now this is my array which is having how many rows? Okay, 2 rows and how many columns? 3 columns. Now if I'm trying to say append, okay, append, if I'm writing a C comma, now this is what I'm adding it. You are adding one new row. You are adding a row. You are appending a row. Now what is the dimension of this array is 2 dimension, and this is having how many rows you want to add it. Now each row is having how many values? 3 values or 3 columns. Now here I'm giving access 0. If I'm writing access 0 is nothing but this is added as a, this row is add. So this element is added as what here? Row. This element is added as what? Row. And each row is having how many values? 3 values or 3 columns. If you are writing access 0, it will add one row. It will add one row with how many values here? 3 values. But if I'm writing column, suppose I want to add as a column, I want to append values at what? Column, then you have to define, okay, you have to define like this. You are trying to say append, you're trying to say append. Now this is an array, comma, you need to create a two-dimensional array. You have to create a two-dimensional array with, you have to create a two-dimensional array with, okay, number of columns here. How many columns you are adding? Now how many values you are adding here? Three values here. See, this dimension is 1 into what is that here? 3. So 1 into 3 means one row. Sorry. So 3 into this is nothing but 3 into what is that? 1 means 3 rows and 1 column. Means each element you are adding as one. Each element you are adding as one row. Each element you are adding in one row as a columns here. It is trying to increase the shape. Which one is increasing here? Which one is increasing here? Number of columns. Means you are adding it as one column. Now number of rows are 3. Number of rows are 3. But how many columns are there here? One column. And each 3 rows, in each row you are adding one column. In each row you are adding one column, and that is represented as one dimension. See here. This is 1, 2, and what is that? 3. So you have to define whether you want to append the elements along with the axis 0. Axis 0 is nothing but rows, and here axis 1 is nothing but what? Columns. Axis 0 is nothing but along with the rows, and axis 1 is nothing but along with the columns here. So 10 and 20. Now which one is changed? It is 2 rows only, but how many columns are there? 4 columns. Now it is increased which one? 3 rows and how many columns here? 3 columns, because you try to add along with the axis 0. And here you add along with the axis 1. Here you add along with the axis 0. And here you add along with the axis 1. So that is the difference between the stacking and what is that? Appending. So append will add the elements. Append will add the elements either row or what is that? Columns, right? So you can see it is add the elements either as a row or what is that? Column. So that is done by using which one? Append. But that will do always at the end, right? So next is, now this is append. Now there is an append and there is a delete. So but append doesn't do the changes in the same matrix or same array. It will try to do changes in what? New array. It will not do the changes in same array. It will do the changes in what? New array. So this is append here. So next one is, there is an operation. So there is an operation called delete. NumPy dot delete. So there is an operation called delete. NumPy dot delete. NumPy dot delete. This append you understood? So if it is 1D array, it will append a value at the end. If it is a 2D array, it will convert into 1D array and append the elements. If you want to append this element as a rows, if you want to append these elements as a rows, then you write access what? 0. If you want to append the elements as the columns, you just give as what? Access 1. Simple. Simple terms you can say this is like this. Okay, this is a matrix with 2 rows and 3 columns. So 1, 2, 3 and 4, 5, 6. Now you want to append how many values? 3 values. 3 values means you want to add one row. You want to append row means you want to append the elements along with the rows. Okay, here you are saying access 0 means it will try to append. What is it? It is trying to append here 7. What is trying to append here? 8. What is trying to append here? 9. So how many values get added here? 3 values. This is nothing but access what here? 0. If you want to add along with the access 1, then you are representing this as what? Columns, right? So rows are 2. Rows are 2. But how many columns here? 1 column. Now this element you are appending in what? First column. And this element you are adding in which column? Second column. That is nothing but access 0. And that is nothing but what? Access 1. So how many values you want to add in each column? See, this is nothing but 2 rows and what is that? 1 column. Means you are adding values in how many rows? 2 rows. How many values you are adding? 1 value. How many values you are adding? 1 value. You are adding 1 value. In this case, now how many rows are there? How many columns? Now in this case, 1 row. And how many columns here? 3 columns. In 1 row, you are adding how many values? 3 values. What is that value? 7, 8 and one more is 9. That's it. It is in simple term. Access 0 is nothing but along with the rows and access 1 is nothing but along with the columns. So the way how you are writing this, in the same way, yes. Yeah, it will always append to the new array. It will not do the changes in the same array. If you print a C array, the C array remains same here. There is no changes in C array. Now you can see it is having number of 1, 2, 3, 4, 5, 6. That is nothing but 2 rows and how many rows? 2 rows and 3 columns. 2 rows and 3 columns, right? Now you can also delete elements from the array. And if you want to delete the elements along with the axis, or if you want to delete the element, you are trying to use a method called which one? Delete. So you have a method called what here? Delete. So that deletes an element. Document definition I'm taking here. So numpy dot delete. So it will delete. So delete method is used to remove elements from the array. But after deleting, it will return what here? New array with the specific element removed. It doesn't modify the original array. It is not in place. It is not in place. Not modify the original array in place. So because why these are not immutables? Because data, once you lost the data, original array will be there. If you lost the data, then you cannot get it, right? Because of that, whenever you do these operations like append, whenever you do the operations like delete, it is not do the changes in which array? Original array, but rather than it will returns what? New array. So after deleting the elements, it will return that into the new array, but it doesn't delete from what? Original array. So if you see the syntax, so numpy dot delete is a function and you just define the array. You define the array and define, you can say object and one more is what? Access. So this is the object is there and one more is what? Access. And what is the default access is 1. So what is it object represents here is index. So 3 parameters are there. One is array and one more is what? One more is what? Object. Object is nothing but what here? Index. For 1D array, object can be integer. For 2D array can be integer or list of integers. Okay. So here object is nothing but index. So object is, so array is nothing but array object from which, okay, elements are deleted. Elements are what here? Deleted. And object is nothing but indexes. Index of elements. Index of elements to be removed. So that is nothing but object. So your access can be either 0 or access can be 1 or access can be what here? None. So access can be 0 or access can be 1 or access can be what here? None. It can be 0 or 1 or it can be what here? None. So that is along with the access, you can delete it. Yes, here after deleting, the changes will be written into new array, but the changes are not written in the same array, right? Just see here. Suppose you create an array again, np.array. So I create an array with some elements here, 10, 20, 30, 40, 50. So this is a single dimensional array or one dimensional array with how many values here? 5 values. And if I'm writing a b equal to np dot delete, I'm saying a comma, I just write here 0. So what is an object is here? 0 I said here. 0 means you are deleting an element at which place? 0. But after deleting, is it do changes in same array? No. If I print A, now is it element is deleted from A? No. Element is not deleted from A. After deleting element, it returns into another array. Now you can see this is an array contain 20, 30, 40 and what? 50. So after deleting, it will return that elements into what? New array. So np dot delete, I'm writing array is A. I'm giving a list of indexes. I want to delete an element at 0. I want to delete an element at what? 3. I want to delete an element at 0. I want to delete an element at what? 3. So how many elements are deleted? So the element at 0, the element at 3. So 10 is deleted and 40 is also deleted. If you want to delete multiple elements, you define multiple indexes as a list, as a list of indexes, as a list of indexes. So multiple elements. If the index is not valid, then it raises what? Error. Suppose I'm creating np.array. Now I'm creating an array of 2D, so which contain some 3 rows and which is having 3 rows and 3 columns. It is having 3 rows and 3 columns. Now it is written like this: np.array having 3 rows and 3 columns. Now I'm trying to print what I'm printing here, D. So this is with the 3 rows and 3 columns. If I'm writing np.delete d comma, I said here 4. I said d comma 4. I said d comma 4. And if I run this, is it given any error? No, because if you are taking access none, if you are taking access none, so this array is converted into which array? 1D array. It is converted this array into 1D array. So that is 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now here index starts at 0, 1, 2, 3. So it will delete the element at what? 4. And what is the element at 4 here? 5. So if you don't give the access, then it will convert this 2D array into what? 1D array. This is called as a flat-ended array. This is nothing but flat-ended array, and then manipulate the index. What is the index of this? What is the index? What is the element at index for 5? So this element get what here? Deleted. This element get deleted, and if I print A, suppose if I print E, now this is which array? 1D array. When if you don't give the access as what? If you don't give the access as 0 or access as what? 1. If you write only index, by default access is 1, access is none. It means it will convert into a flat-ended array, or it will convert into what? 1D array and then delete it. If I'm writing np.delete d comma, I said d comma 0, d comma 0 comma access 0, d comma 0 comma access 0, access 0. Now it's nothing but a row, right? Access 0 is a row. Now first row get deleted or not? Yes. Now this array is having how many rows? 2 rows. That is 4, 5, 6, and one more is what? 7, 8, 9. Access 0 is nothing but row. You can also define multiple indexes. You can also define the multiple indexes by saying d comma, okay, multiple indexes. I want to delete 0 comma 2. 0 comma 2 access 0, I said again. If I print G, now this is one array, but from this you deleted how many rows? 2 rows. Means you deleted first row and you deleted what? Last row. Access 0 is nothing but a row. You're deleting first row and you're deleting what? Last row. Because what is the index of first row? 0. Because it is having 3 rows and 3 columns. What is the index of first row? 0. What is the index of last row? 2. 0, 1, 2. So you are deleting rows. You want to delete along with the columns. Okay. You are trying to say np dot delete. np dot delete d comma. I want to delete one column. One column means you need to give access what here? 1. Access 1. This is deleting a column. Means the shape of the array get changed, right? If you see this one, you can see actually it is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. This column is get deleted or not? Yes. Now you can see this is an array with how many columns are there? 2 columns. With how many rows are there? 3 rows. So that is done by using which method here? Delete. Along with the access. Now you can delete multiple columns. You can delete multiple columns by writing np.delete d comma multiple columns. I want to delete the column at 0 and I want to delete the column at what? 2. It means now this is a matrix with number of rows and this is a matrix with number of rows and columns. Now you can see 1, 2, 3. This is 4, 5, 6, and this is what here? 7, 8, 9. This is 0, 1, 2, and this is 0, 1, 2. You are deleting which column? First column and what? Last column. Column means you have to give the access. Access what? 1. If you give access 1, then it will delete what? Column. So two columns get deleted. That is the first column and what? Last column. Now remaining how many columns are there? Only 1. So if you want to delete along with the access 0 is rows and access 1 is columns. If you don't give the access, it converts into which array? 1D array and manipulate the index and then delete the element. If you don't give the access, what is the default access is 1, a none. None means it will convert 2D into what? 1D and then manipulate the index and then delete the element. So that is done by using which function? Delete function, right? Yes, this is about delete, but it is mutable or immutable? Immutable. So these are immutables only. These are not mutables. These are what? Immutables. Okay, right? Now then next one is, so numpy dot insert. So next one is numpy dot insert the data. So generally all these are useful. You are giving all this data. So this data you are taking or you are loading data. You are loading data. You get the data. After getting the data, what do you have to do? Data pre-processing has to be done. So data pre-processing. You have to process this data. So to process this data, you either add the data, you delete the data, you insert the data. Okay, all these operations you do it. So that is nothing but data pre-processing. Handling missing values, replacing the missing values, all this is called as data preparing, right? Organizing the data. And after preparing the data, this data is used for what? Analysis. This data can be given to what? AI models. This data can be given to which one? AI models. Getting on. So it means there is one person who's called as a data engineer. There's one person called data engineer whose role is ETL, extract, transform, and load. Getting on. So this person will clean the data and organize the data, structure the data, and this data is given to whom? Data scientist. Or this data is given to what? AI engineers, so that this data can use. But nowadays, the person who work with AI or who work with the data science, even he must have a knowledge of which one? ETL processing, because it's called as a full stack, right? Then he should have a knowledge of ETL, right? So, but that is for that you'll be using another library, and what is that is PySpark. What is that library you are using? PySpark. Why? Because this data is huge. Huge data means big data. You'll say no, big data, big data. So data is not small. You'll get large amount of data. Then you have to divide, merge, mapping, reducing, all this you have to do it. And those operations done by using which libraries like PySpark. And PySpark is a library which is built on the top of which one? NumPy. It is built on the top of NumPy, and one more is what? Pandas. Okay, right? So it is very important if you are moving towards a data science and what do you call it as artificial intelligence. Data science and artificial intelligence, right? Because data is important. Data is important. So I say no, AI given training, AI given training, AI train. What it trains? Okay, AI train. What it trains here? Data. You give some data to the AI model. What AI model will do? It learn from this data. Training is nothing but learning. It learn from this data. It identifies some patterns on this particular data. Getting on. So you give the training to the data. I mean, model train on which one? Data. For example, you ask the chat GPT, who's the Prime Minister of India? So it will tell the answer or not. Yes. It means that model is given training on which data? Historical data or not? Yes. Suppose if the training is training, if this model is trained on 2023, then you'll get the answers belongs to 2023. Because this model is trained on which year? 2023. Then at that time, who is the prime minister? It will tell you. At that time, who is the prime minister? It will tell you. Because it is trained on which year? 2023. Getting on. So it means this AI model should keep on what? Updating. Otherwise, we'll get accurate answer or different answer, different answer. Suppose you take in training on Python 3.10, but current version is 3.14. You know only 3.10, but you don't know 3.13. So AI also same thing. AI is given training on large amount of data, or huge set of what data. So this data is taken from books. This data is taken from blogs. This data is taken from what do you call it as tutorials, or it is taken from internet or databases. From different sources, it will take this data and it is given what? Training. Understood? So it is just like a human brain. It is just like a human brain uh, where you have some neurons, right? Right? So that is where you find a neural network. Okay. You find different types of algorithms. It's nothing but advanced predictions. AI is nothing but predicting. Next, next word, that is what will happen when you work with a chat GPT. Getting on it, generate the new text. So there is a traditional and there is a generative. There is a traditional AI and there is a generative AI. Traditional AI is just like a search engine where you'll get the existing. But generative AI, it generates what? New text. It predict the new text, new images, new text that is generated by what? Generative AI. But traditional AI, what it will do? Whatever data it is trained on, that data it will get it. Whatever data it is trained on, only that data it will get it. But if you want some new data, then you have to go for another model, which is called as generative. Generative AI means it will generate a new images, it will generate the new text, it will generate the new video or audio. That is what you see. Getting on it. If you type some text and you want some image, will it generate it or not? Yes. So that is generative AI models. Understood? Right? So, but data is important. This data is stored in data structures. Data is stored inside what? Data structures. You organize. Structure means organizing. Particular order. You may organize in rows. You may organize in rows and columns. Getting on not? You may organize in rows. You may organize in rows and columns. I say no, like image processing. How image is represented as a two-dimensional array. How image is represented as two-dimensional array. And you may do certain operations on that data. Now you may append the data, you may delete the data, you may replace the data, you may insert the data. Yes or no? Suppose image is there. Image is with some dimension. Image dimension is some 100 into 100. I want to increase the size. I want to increase the size. That is, you may increase the size of either width or what is that? Height. Increasing the width and height is nothing but you need to change what here? Shape. Shape of the matrix. You have to change the shape of the matrix. Now I'm changing it to 200 into what is that? 200. Then what will happen? The image size get increased or not? Yes. But when increase the image size, is it original data may lost or not? Yes. You may not see that much clarity, right? Because you may replace with some data. You may replace remaining 100 into 100, you replace with some data. Getting on it. In the same way, you want to rotate the image. You want to rotate the image horizontally or what? Vertically. You will say no, sketch and skew. Okay. So you rotate it. But how all these are done? By using which operations? Matrix operations only. Understood? So the data you move it. You rotate the data. Rotation. You will say no, left rotation. When you work with arrays, you will try to learn. When you work with arrays, you will say left rotation, right rotation. Getting on. So what you are rotating? Elements. Number of positions. Number of positions, you rotate it. So that is nothing but changing the angle of which one? Image. So all these are useful when you are working with the what do you call it as in AI? AI you have a two parts, right? What is that? Machine learning, and one more is what? Deep learning. Machine learning deals with only text, and deep learning deals with what? Images, binary data like images, audio, and what is that? Video. So for this, you will be using one library. And what is that library? OpenCV. And this library again built on top of which one? NumPy. This OpenCV, again it is built on the top of which one? NumPy only. Understood? Right? So all this is required. All these are required if you want to move towards a. So that's the reason this module is for Python for data science. This Python, what you are learning, this module is Python for data science. It is not Python for Django. It means these modules are using in Django, na? No, you're not using in Django, right? If you want, you can use it. If you want to represent sales in the form of charts or graphs, then what do you do it? Compulsory, you have to go for which one? NumPy, Pandas, and Matplotlib. Analysis. If you want to do analysis, okay. So even the data science person need to have a knowledge of which one? Django. What is that? Flask. You should know this because it deploy the model. Suppose if you take ChatGPT is there. What is ChatGPT? What is ChatGPT? It's a web application. It is a web application. It is a web application. What is the model name is? GPT. GPT is a model. What is the name of the model? A model name is what? GPT. What is a ChatGPT? It is which application? Web application. It is a front end. It is a chatbot. It is a front end where you type some text and that call is sent to which one? Model. By using some APIs or not? Yes. It's a backend. It's sent to the backend and backend communicate with what here? Model. Getting on. So it means the person who learn AI or who build models, then even to test and deploy and test, then you need to have knowledge of which one? Knowledge of which one? Backend as well as the front ends like HTML, CSS, and what is that? JavaScript. But anyway, those technologies nowadays, the person required to have a lot of technologies. Not one technology is not enough. One technology is not enough. Now, this technologies, every person must have a knowledge. So, must have a knowledge of, now previously, the student must have a knowledge of OS. But now student must have a knowledge of which one? Cloud. Because in companies, you'll be working on which environment? Cloud environment. And not only that, you must know one more knowledge. What is that? DevOps means you need to have some tools, development and deployment tools, right? And at the same time, the person must have a knowledge of, which one? Cyber security, because you try to develop the application and your application should be a secured or not. Yes. Now you need to know ethics of what? Cyber security. It means if that you learn it once you join in the company or once you start developing which one? Applications. But as a fresher, now you need to know only one thing. What do you need to know? Python. So Python with data science or Python with AI or Python with something else, right? Yes. But anyway, now there is one more function is there. What is the name of this function? NumPy dot insert. So if I keep on telling the functions of NumPy, it will take 1 year also, because those many number of functions are there in NumPy. So this is never end. Okay, we have to stop somewhere, right? So this is never end, but you need to learn certain things belongs to what? NumPy, which are frequently used in development of what? Applications that you are learning it. But when you are saying it is a library, you find a lot of functions. When you are saying it is a library, you find a lot of functions, not one function. You find so many functions here. So numpy dot insert. Now this is for inserting data, or you can insert the values along with the access by using which one? Insert. The way how you are doing delete, right? In the same way you can do what here? Insert. So insert along with the access. I'm not taking my definition. I'm taking document definition, right? It is insert values along with the access, but this is also immutable. This is not mutable. This is also what? Immutable. So numpy dot insert function in Python numpy library is used to insert values into an array before a given index or indexes. Along a specified axis, it returns a new array with the inserted values. So leaving the original array what? Unchanged. Original array unchanged. And if you see the syntax of this, now you can see this is a syntax. NumPy dot insert, same syntax of delete. So NumPy dot insert, array is there and index is there and values, and this is along with the access. So here, now these are parameters. What is a parameter is? Array object name, where you want to insert. Object is nothing but what? Index or indexes. So multiple indexes, or it can be one index or multiple indexes. Okay. Then so multiple indexes and then values. So the values to be inserted, and here access. Default access is what here? None. Default access is none, but it can be what? Access 0, or it can be what? Access 1. It can be access 0 or it can be access 1. Access 0 or access 1. So it can be access 0 or access 1 here. See here. Now what I'm doing is same here. So np.array, I'm creating an array with number of values. Now this is an array created with some 5 values, and b equal to a dot insert means it will insert before index or not. Yes. What is the name of the array is a, and what is the index I've given? 0. What is the name of the array is A. What is the index I have given? 0, comma. What is the index I have given? 0, comma. The value which I want inside is 10. You can see print B, but it will not do changes in A. Sorry, NumPy. So if I now the value get inserted here. So the value get inserted here, right? What is the value get inserted here? 10. But this value get inserted at which place? 0. This value get inserted at which place? 0. Now I'm saying np dot insert a comma, give the index where you want to insert it. 4. I just write here 99. Yes. Now if I say print C, now this value is inserted before 4. Before 4 means now this value is inserted as a 4. 4 means now you can see 0, 1, 2, 3, and what is this? 4. As an index 4. Now what is the value is inserted here? 99. But now if I'm writing np dot insert a comma, I want to insert 4 comma, I just write here 10 comma 20. Now here I just try to give how many values here? 2 values. What is the first 10 and one more is what? 20. And here I'm saying print D. Now when I say print D, now 4 onwards, it is inserted how many values? 2 values. From 4 onwards, it is inserted how many values? 2 values. क्लास नंबर क्या है यार? Which class number क्या है? हाँ, खान भाई, what is this class number? ये class number क्या है यार? Classroom code है? Is asking classroom code or what? Huh? Classroom number on, sorry, classroom code only. Classroom code पूछ रहे क्या? खान, ए खान, क्या यार उनका नाम? अब्रार खान. So np dot insert. Now create one more array here. So np dot array. Yes. So 1, 2, 3. Now I take. So these are called some crude operations, right? These are just like a crude operations, right? Now this is an array created with some 3 rows and 3 columns. Now what do you want? Suppose you want to insert a row. You want to insert a row. So I'm writing here np.array e comma. Now I want to add a row. So 10 comma 20 comma 30, and here I'm writing access is what? 0. I said access 0 means you are inserting as a row. Sorry, position you have to give at what here? 0. The position is 0 here. How many are given? What is the name of the array? E. So see dimensions. Array no insert. So what is the name of the function is? Insert. You can see it is inserted one row at which place? 0 place. So the row which you want to insert, that you represent as which array? 2D array. How many rows you want to insert? For example, some g equal to np dot insert e comma at 0 only. At 0 only. I want to from 0 onwards, I want to insert 2 rows. 10 comma 20 comma 30 comma 40 comma 50 comma 60. Then here I'm writing access 0. When I write access 0, now you can see It is trying to insert how many rows here? Two rows are inserted. From which place onwards it is inserted? Two rows. Zero place onwards. Now it is inserted how many rows? Two rows. Now this is the first row. See here. This is the first row and this is what here? Second row. But you want to add it as a columns. You want to add as a columns. So here I'm writing F equal to NP dot insert. So E comma, I want to insert one column at 0 here. Column means one row with multiple columns. 10, okay, 20, 10, 20, and one more is what? 30. Now these values to be added along with what? Axis 1. Axis 1 is nothing but, here axis 1 is nothing but column. Axis 1 is nothing but here, along with the columns you are adding it. You are adding along with the columns. Now, yes. But what is the matrix here? Here. You write it as a single dimension here. I've done the mistake here. Take as an array with number of values, but you are inserting as a columns. You can see 10, 20, and what is that? 30. But you need to define this as an array. Now, how many values you want to add? Define that. And you are adding these values along with the axis 1. Axis 1 is nothing but number of, yes, columns here. Axis 0 is a rows and axis 1 is a columns. Axis 0 is a rows and axis 1 is a columns here, right? So that is inserting. You can insert multiple, but multiple means you have to define multiple data. Multiple data. If I am writing np dot insert e comma 0 comma, now I am saying here 10, 20, 30 comma 40 comma 50 comma 60 comma axis 1 means it will add this as a rows or columns. Columns. If I'm writing print, okay, print j, now it will add as a columns. Now you can see 10, 20, 30 and 40, 50 and what is that? 60, right? Yes. So if you want to insert the data into the array, you are trying to use a function called which one? Insert. So that is along with the rows and columns, that is represented by using axis 0 and one more is axis. One is axis 0 and one more is axis 1. Axis 0 and axis 1. Right? Yes. Then next one is I want to replace the data. Now this is mutable. Replacing is mutable. Replacing is what here? Mutable. Before index. It will insert before index means, now I said here 0. It will insert at 0. If I say 1, it will insert at what? 1. Before index means already at 0, 1 is there, right? At 0, already 1 is there. But if I say 0 again, insert at 0 means what will happen? Before index means now these elements are shifted which side? Right side. These elements are shifted which side? Right side means, and the new element is inserted at what? 0. New element is inserted at what? 0. Right? This is replacing or updating elements of array. Replacing or updating elements of array. So replacing is a mutable operation here. You don't have any functions or methods. Okay. Always replacing is done by using index. There's no methods or no functions here. So replacing. So replacing is a mutable operation. Mutable operation. Okay. So it means you are trying to do changes in original array, and this replacing of elements A replacing of elements are done using using what? Index, and one more is what? Slicing. This replacing is done by using an indexing, and one more is what? Slicing here. It means you can replace one value or you can replace multiple values. If you want to replace one value, then use what? Index. If you want to replace multiple values, then use what? Slicing. Because slicing generates one index or more than one index? More than one index. Slicing doesn't generate one index, it generates multiple indexes. Just to see here, I create an array again. NP dot array, I create an array with some values here. Now these are the values exist in the array. Now this is an array with some 4 values. This is an array with how many values here? 4 values are there. Okay, now I want to do the replacement here. I want to replace the values. Then how can I replace the values? How can I replace the values? I'm writing here a of 0 equal to 99. I write here a of 0 equal to 99. When I say a of 0 equal to 99, so the value at 0 get replaced here. So the replacing is done in the same array here. Same array. A is modified. The value at 0. What is the value at 0 here? 10. And the value at 0, 10 is replaced with what? 99. Okay. Now suppose if there is a, yes, I want to replace multiple. I want to replace multiple. How can I replace multiple? Can I use index slicing? Colon 3. I said colon 3 means colon 2. Okay. Colon 2 means 0 and 1. 0 and 1. Now here I am writing some 100 comma 200. 100 comma 200 I have given. See what is the elements I have given? Sorry. 100 and 200, and then I say print A. So when I print A, now how many elements get replaced? 2 elements. That is nothing but 100, and one more is what? 200. So if you want to replace one value, go for indexing. If you want to replace multiple values, then go for slicing. Suppose assume that I have another array which is two-dimensional array. Two-dimensional array. I have a two-dimensional array. Can you replace the selected elements? For example, A of, I'm writing 0 comma 1 like this. Can I write? 0 comma some, okay, 2. 0 comma 2. 0 comma 2 I said. 0 comma 2 equal to some 99, and I've just given 88. Means I want to replace two values. Sorry. The value at 0 and the value at what? 2. So selected index also you can give. Now you can see the elements are replaced. The value at 0 is replaced. The value at which one? 2 is replaced. But how you are writing a multiple indexes as one list which contain how many indexes? Multiple indexes. In the same way, now you have another array, np dot array. Now this is which array? 2D array. 1, 2, 3, comma 4, 5, 6, comma 7, 8, 9. 7, 8, 9. Now this is 2D array with some 3 rows and 3 columns, right? If you want to replace it, then compulsory you have to give 2 indexes, right? That is a row index, and what is that? Column index. I'm writing B of 0, 0 equal to 100. So it is replaced the element at what? 0, 0. 0, 0 is replaced with what here? 100. You can write like this, or you can also write B of 0, 0 as separate. Equal to some 200. Now 100 get replaced with what? 200. See here. 100 is replaced with 200. Now this is nothing but 0, 0. This is 0 row and 0 column. You can define the row index and you can define what? Column index. If you want multiple indexes, can I replace? I can write, what I can write? 0, can I write 0 colon 2? 0 colon 2 means how many rows? 2 rows, right? 0 and 1, comma, slicing. Can I write slicing like this? 0 colon 2 means 2 columns. This will written what? 2 rows and 2 columns here. In one more list. B or A? Na? Is it B or A? Inside only. This is. Now B of 0 colon 2 and 0 colon 2. What happened here? This is a row and this is column. 0 colon 2, 0 colon 2. The rows and one more is what? Column. Now 2 rows and what is that? 2 columns. Now it is read 2 rows and 2 columns. Now this is 0, 1 is a row and this 0, 1 is what? Column. Now can you replace this number of rows and columns can be replaced? Tell me, can I replace it or not? Suppose if I replace like this, I'm writing it as a 11, 22, comma 33, comma what is that? 44 I've given like this. I've given like this. Print it. So print. What do you print here? B. See, by using slicing, you can replace either one value or you can replace what? More than one value. Now this is a row slicing. This is a row slicing and this is column slicing. Means you take how many rows? 2 rows. 2 rows. 2 rows and 2 columns. Here, 2 rows and 2 columns get replaced. First row get replaced with what? 11, 22. And second row values get replaced with what? 33 and 40. So you can replace either one value or more than one value. So that is done by using either index. That can be done by using index or one more is a slicing, right? Yes. So this is replacing here. Okay. So NumPy package, I can say NumPy package is having one more module called matrix. Okay. There's one more module is there in NumPy and that is nothing but NumPy dot, what is the name of the module? Matrix module. Now where you can perform operations on what? Matrices. Okay. So NumPy dot, now next what I'm talking about is matrix module and after that we'll be talking about linear algebra module where we'll try to solve some linear equations. There is a module NumPy dot. What is the name of the module? Matrix. See, NumPy having so many modules. NumPy is having so many modules and one of the module is what here? Matrix. NumPy dot matrix. Here, NumPy dot matrix, not matrix class. So the NumPy matrix, okay, NumPy dot matrix module is there and it is a library and that will perform the operations on which one? Matrices. So we'll talk about this, like how to work with this NumPy dot matrix, right? But not today, but we'll try to see this in tomorrow's class, right? So after this matrix operations, we'll go for linear algebra, right? Yes, thank you. We'll see tomorrow.